Welcome back for lesson 10 today. This is Mrs. Lehman from Math with Mrs. Lehman. I'm here with my 6th period class. Say hello, everybody. We are working on our bell ringer right now. It says complete the ratio table, so somebody already figured out that if we have 4 dresses, we would have 6 pants. So if we have 6 dresses, we would have 9 pairs of pants. 8 and 12. Who can tell me what this next missing value is? Brianna.
10.
She said 10. Who agrees with Brianna? You guys would be correct. Nice job. Okay. So the second question here is, what is the value of the ratio that this table is based on? Can someone tell us what we mean when we say what is the value of the ratio? Does anyone know what we're talking about? Jordan?
It's the simplest form.
Very good. It's the simplest form of any of those ratios. So what is the simplest form here? Michael?
4 to 6.
4 to 6. Can we simplify 4 to 6? Yeah, so we have to go lower. Christoph, what would that simplified be?
2/3.
2 to 3. Very good. So the ratio that this table is based on is 2 to 3. If we were to simplify any of these ratios, it would simplify down to 2 to 3. Okay? Any questions on this? All right, we're going to move on to our math joke of the day. So it says the following fractions: 5/3, 9/2, 6/5. And the teacher says, no, you don't need a permission slip to learn about improper fractions. A lot of people don't get it. Does anyone know if something's improper, should we do it? No, right? So these kids are questioning, should they be learning about something that's not proper, not appropriate in a way. Okay, haha. Okay, moving on. We are on our homework from yesterday, so we're going to go through this really quickly. Upon checking everyone's homework, it looks like most people had a really good handle on this. So it says a father and his young toddler are walking along the sidewalk. For every 3 steps the father takes, the son takes 5 steps. So first of all, we're going to make a ratio table out of this. So what should I have as a heading here? Jacob.
Father.
Very good. And the other column will be?
Son.
Very good. So a lot of people were missing this on their paper. So go ahead and write father and son. And that ratio was what? What ratio was that, Riley?
3 to 5.
Very good. 3 to 5. The father most likely has much longer legs, right? So he's not going to need to take as many steps as the son. So if we were to double that, right, we have 3 for the father now, but if we were to double that, we would have what?
6 to 10.
Very good. So the father takes 6, the son takes 10. Who can tell me the next one? Nadia?
9, 15.
Very good. 9 to 15. And the next one, Malaya?
12 to 20.
Very good. 12 to 20. The next one, Tori?
15 to 25.
Very good. 15 to 25. And last but not least, Cassie?
18 to 30.
Very good. 18 to 30. Raise your hand if you had that correct. Nice job. If you had a different ratio somewhere on there, that would be fine as long as it's simplified to what? Stephanie?
3 to 5.
3 to 5, right? 3 to 5, yep. As long as it is all based on this simplest form, you were good. All right. The next question was, what can you say about the values of the ratios in the table? So the values of the ratios. right, are what? Somebody said it. Who haven't I heard from yet? Is there anyone who hasn't been on there? Brianna.
The value of the ratio in the table are 3 to 5.
3 to 5, and we'd also say they are all
Equivalent.
equivalent. Very good, everyone. So I'm going to say equivalent to 3 to 5. Okay, so some people had part of that, some people just had 3 to 5 written there. So make sure you finish that sentence up and say that they're all equivalent. If it's a ratio table, all of the values should simplify down to the same thing. Yes, Christoph. Okay, so Christoph just worded his differently. He said they are equivalent to 3 to 5. That's perfectly fine. All right, any other questions? Okay, we are moving on to today's lesson, which is going to involve the structure of ratio tables, lesson 10 from module 1, additive and multiplicative. So it says, imagine you are making a fruit salad. For every quart of blueberries you add, for every quart of blueberries, let's underline that, you would like to put in 3 quarts of strawberries. Right, we are going to create 3 ratio tables that show the amounts of blueberries and strawberries you would use if you needed to make fruit salad for greater numbers of people. So, table 1 should contain amounts where you have added fewer than 10 quarts of blueberries to the salad. Table 2 should contain amounts of blueberries between 10 and 50 quarts. And table 3 should contain amounts of blueberries greater than 100 quarts. So first of all, let's talk about what a quart of something is. A lot of kids earlier were trying to tell me that that was 1/4 because they were thinking it was the word quarter. All right. Does anyone know what a quart measures? Jordan?
Like 1/5 of a pound? 1/10?
Nope. You're thinking of it as a number.
1/4 of a gallon?
Nope, you guys are thinking of it as quarter, and the kids have been making that mistake all day. Quarters are 1/4 of something. A quart is just simply a measurement of volume. Okay, so how much something holds. So you guys have seen those little containers, green type containers of strawberries out at maybe a farmer's market or something. That's a quart, okay? So that's just giving us the unit of measurement. So we have 3 quarts of strawberries, but it says for every quart of blueberries. It does not tell us what that number is. We know there's a ratio because we see the words for every, but there is no number here. It just says for every quart. Does anyone know what number is implied if they do not give a number when they say for every? 4? Nope. Again, you guys are getting hung up on the idea that a quarter involves 4, but this has nothing to do with 4. This has to do with for every, and then they don't give a number. You know, Jonathan?
1.
Very good, Jonathan. 1. So let's write above that 1. So if it says for every something, could be strawberries, blueberries, pants, dresses, whatever you're talking about. If they don't give you a number, it is 1. Okay? You were gonna say that. Okay. Let's go ahead. The first table has to have fewer than 10 quarts. So let's just do 1, 2, 3, 4, and 5. All right. So let's talk about the quarts of strawberries. So this was based on the ratio of 1 quart of strawberries, 1 quart of blueberries had how many quarts of strawberries?
3.
3, very good. So we're going to use that ratio to scale these up. So what would the next box be? Tori? 6. Very good. So we're going to write 6 right here. And then 3. Stephanie?
9.
9, very good. Are you guys starting to see a pattern emerge? Okay, the next one, Nadia.
12.
12, very good. And the last one, 5, would be what, Christoph?
15.
Very good. All right. So there's a few patterns that you guys are noticing. Does anyone want to tell me what pattern they are seeing as they look at this table? What's one, Michael?
Each one is multiplied by 3.
Very good. So to get from blueberries to strawberries, you just found the multiplicative aspect of that. So you take this times 3, you get 3. You take 2 times 3, you will get 6 times 3, you get 9 times 3 is 12 times 3 is 15. So very good. What else did we notice?
That each ratio is equivalent to 1 to 3.
Very good. If we were to simplify any of these ratios, it would simplify down to 1 to 3. You just gave me the value of that ratio table. All right. Any other observations that you have, Jordan?
As you go down the column, you add 3.
All right. Which column? Very good. Because we're basing this off a ratio of 1 to 3, the strawberries keep increasing by adding 3, by adding 3, by adding 3. Okay? So that continues. Each time we add 3 to the strawberries, how many do we add to the blueberries?
1.
1. Very good. All right. So I'm going to erase some of this extra stuff I've got going on here. So we increase the blueberries by 1. We're increasing the strawberries by 3. We keep doing that repeatedly. That's why we might say if we, oops, I'm trying to erase things. If we double this, we've got to double this, right? If we triple this, we have to triple this. So there's lots of different ways we can look at this. Let's look at table 2. We have to have between 10 and 50 quarts, so let's do that. 10, 20, 30, 40, and 50 for blueberries and for strawberries. All right, let's look at that rule that Michael gave us. He said that in all of these, we multiply it by 3. So let's do the same thing over here. We have to triple our blueberries to tell us the number of quarts of strawberries. So what is 10 times 3? 30. Very good. I'll have you guys just say the next one's really loud. What would the next one be, everybody? 60. Good. Very good. 40 times. You guys are good. 50. You got it. Okay, nice job. So we could do this for any amount of blueberries since we found that connection. Let's go to the last table, which they want us to do numbers greater than 100 quarts. So let's do 200, 300. Let's skip some, should we? 500. Some people are saying, no, don't do it, Mrs. Lehman. All right. Too bad. Evil laughter. All right. So 200. What rule are we going to apply to all of these when we're talking about our blueberry to strawberry fruit salad recipe? We're doing what to the blueberries every single time?
Multiplying them by 3.
Very good. If you couldn't hear Jonathan, he said multiplying them by 3. So 200 times 3, kids? 600. Very good. 300 times 3? 500 times 3? Beautiful. Next one? 1,800. And very good. So you guys did a nice job with that. Are we ready to move on to the next set of questions? All right. We're going to skip over some of the questions in here. That's okay. We're just going to answer a few of these on the next page. It says, G and H, pretty much what we need to do is talk about what rule applies to all of those. And I think you guys have already done a nice job. You've already done a nice job discovering what that pattern is. All right, so to get strawberries, you need to do what to the blueberries?
Add 3.
Not add 3. Multiply by 3. Very good. So we're going to kind of use this answer for G and H. We need to multiply the blueberries in our first column there by 3 to get the number of strawberries.
All right, this is Mr. Mattingly doing a guest appearance in Mrs. Lehman's math class. If we know we want to add 7 quarts of blueberries to the fruit salad in Table 1, how can we use the table to help us determine how many strawberries to add? Does anybody remember the ratio that was used to build Table 1? Mr. Cambridge. What was it, Aiden?
1 to 3.
Very good, 1 to 3. So let's just write that. If we're using a 1 to 3 ratio, and we want 7 quarts of blueberries, what would we have to do to the 7 quarts of blueberries in order to find out how many strawberries or how many quarts of strawberries we'd have to use? Yes, Riley?
You would have to multiply it by 3.
Yes, we'd have to multiply that by 3. So we could just say multiply 7 by 3. All right. And part L says if we know we used 70 quarts of blueberries to make our salad, how can we use a ratio table to find out how many quarts of strawberries were used? This time we used 70 quarts of strawberries. Again, what was the value of the original ratio? Cameron?
3. 1 to 3.
1 to 3. Very good, 1 to 3. So if we have a 1 to 3 ratio again, what are we going to do to 70 quarts of blueberries? Christoph?
Multiply it by 3.
Very good. We're going to multiply that value by 3 as well. So multiply 70 by 3. Now, how many quarts of strawberries would we have if we had to multiply 70 by 3? Let's see if you guys can just say this all together as a group on the count of 3. Ready? 1, 2, 3. 210. Very good. All right. Up here, if we had 7 quarts of blueberries, how many quarts of strawberries would there have been? On the count of 3. Ready? 1, 2, 3. 21. All right. There we go. Is that pause? Right there?
I think you clicked the stop button. You got it. Hi, it's Mrs. Lehman again, your boring math teacher. Aw, just kidding. All right, so now we're going to take a look at exercise 1 on the next page. And we are going to fix somebody else's mistakes. It says the following tables were made incorrectly. So these are not correct. We need to find the mistakes and create the correct ratio table and state the ratio that was used to make the correct ratio table. So this person who worked 3 hours got paid $24. We're going to call them person A. Person B worked 5 hours and got paid $40. Person C put in 7 hours of work, got paid $52. And person D, after 9 hours of work, received a paycheck for $72. I'm going to pause this video in a second. While I have it paused, I want you guys to figure out who needs to go complain about their paycheck having a miscalculation. All right, so take a second and figure out which person, A, B, C, or D, did not receive the proper amount of pay. Okay, so the hint is for anyone who is struggling with this, let's figure out what this ratio table has a value of. All right, so what could we simplify that down to, Michael?
1/8.
1 to 8 is what we would say. Very good. So for 1 hour of work, you're getting paid these people are getting paid $8. Okay? So take a look at your table again and tell me which person, A, B, C, or D, received the wrong amount of pay. All right, I'm going to go to Joey. Joey, you want to tell us? You want to tell us who got paid the wrong amount? Person A, B, C, or D?
C.
C. Who agrees with Joe? It is C. All right, yes, you guys are correct. What should his or her paycheck, what should that have been? Instead of $52, it should have been, Stephanie?
56.
Very good, because 7 times 8 is 56. So right here in this next chart over, we're just going to copy that info down correctly. So 5 to 40, 7 to 56, and 9 to 72. And that ratio that Michael told us earlier was 1 to 8. All right, we have 2 minutes. Let's look at this next one really quickly. This one is a real big mess. We have somebody mixing blue and yellow or counting blue to yellow. I don't know what's going on here. They didn't give us the context, but if we have 1 blue to 5 yellow, if we had 4 blue, if this were the ratio we're basing this table off of, what should that 8 have been? Jacob.
The 8 should have been 20.
20. Why 20? I'm going back to Jacob.
Because 5 times 4 is 20.
Very good. Jacob, notice that you multiply each of these by 5. That would have given you 20. So 7 times 5 should have been what, everybody? Let's see if we can hear it on here. 35. Yep, 35. Good. And 10 times 5 should have been 50. Nice job. Okay. Lastly, we're going to take a look at your homework for tonight. This next page is a review page. If you want to take a look at that, it's another explanation of what we just talked about. And the problem set is your homework. It says, create a ratio table for making lemonade with a lemon juice to water ratio of 1 to 3. Show how much lemon juice would be needed if you use 36 cups of water. I do not want to see anybody come in here with a chart with 36 rows plus a title row, okay? You guys can simplify, use that simplified value to make that a little more efficient than doing 36 rows. Does everyone understand what I mean by that? Back here when we talked about our fruit salad, we did not need to make a table with 50 rows or with 200 rows, right? We were able to make that a little more efficient because we knew the multiplicative part of this that told you to multiply by 3 in that case, okay? So when you're making your lemonade table, do the same thing. Your homework is to finish that page, and we'll go over that tomorrow, guys. Thank you very much for watching our video. Don't forget to like and subscribe. 6th period, say goodbye. Bye. Thanks, bye.